Okay, sorry for the abrupt ending last time. I think we're up to here, and the secret to finding factor theorem is knowing that when a factor is x minus 1, the root is plus 1, and that when plus 1 is put into this formula for x, if it comes out 0, then x minus 1 is indeed a factor. And that's all about what the factor theorem says, that the remainder will be 0 if the root, when inserted into x, comes out as 0 if it's a factor. And that makes sense because factors tend to be on the x-axis when y is 0, right? That's essentially what we're doing. So the factor theorem says we just have to continually plug in plus 1, plus 2, plus or minus 2, plus or minus 3 to figure out the factors. You should always look for situations here, like sometimes I've missed some, where you can factor out an x. It'll make your life a lot easier because then you're only working with a cubic instead of a quartic. You should also look for situations where you can factor out a number because that'll make the possible factor smaller. In this case, we're looking for something that can multiply out to minus 48, so pretty endless in the factors. So our first step is to take this and realize that when we factor out an x, we're left with x cubed plus 8x squared plus 4x minus 48. That makes our life a lot easier. So x cubed plus 8x squared plus 4x. Now also take note that if I put something like a 1 in here, all these numbers will be a positive, and then I'll be subtracting like 48. So I'm looking at 13 minus 48. So it's quite clear that 1 and minus 1 are not going to do the trick. Minus 1 is even worse because it makes this one and this one negative. So I'm looking at 2 and up. You can save some time. Just looking at 2, I have to say I'm probably going to aim towards a positive number because of this big minus 48 here. So if I start with 2, this becomes 8. 2 times 2 is 4 times 8 is 32. And then this last one is 8. You can immediately see that this adds up to 48. And so that when I subtract 48, I get 0. So that means x plus 2 is a root, which means, plus 2 is a root, which means x minus 1 is indeed a factor. So our next step is to factor out x minus 2 as a factor. The secret there is to use synthetic division. So we already have this x as a factor, because synthetic division is going to be much, much faster. Oh, I should keep this as the main problem in case I make an error. All right, so we've already discovered that 2 is a factor, and the numbers in front of these are 1, 8, 4, and minus 48. I just make lots of space because it just makes things a lot easier for me. So I'm using the coefficients in front. Doesn't matter if that's crooked or not. And I'm using the number 2. Now the nice thing is that indeed, because the factor is x minus 2, I know that there's nothing in front of this x to make things trouble. So I lower the 1, I multiply by 2, I get 2. I add these, I get 10. You should come out as 0. If you don't, you did something wrong. Multiply this, I get 20. When I add this, it's 24. When I multiply this by 2, I get 48 positive. And obviously when we add that, 0. So I know that I did the correct result. So now I'm left with this. X minus 2 is the next factor. I'm just going to lower it a bit. And I'm left with 1x squared plus 10x plus 24. And you should immediately say to yourself, knowing, oh, that's 1x squared here. Okay, so x squared. You should immediately say to yourself, with your knowledge of factors, is there a number now that multiplies out to 24, the last one? So, standard factoring, is there a number that multiplies out to 24 that adds up to 10? And right away I can tell you, if you're not certain about this process, come up with all the factors of 24. Now I already know what it's going to be, and you should too at this stage. And you can see that's 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then that's pretty much it. Then you can just see if any of those add up to 10. It's clear that that doesn't, that doesn't, that doesn't, and that does. And it's nice when they're all plus and plus, because then you're just working with adding them up. So we can see it's 4 and 6. So right away, that means my last factors here are indeed x plus 4 and x plus 6. And we're done. If in doubt, if you have time on a test, you would then expand all of this again. You'd reverse the process. You'd start by expanding this, and then maybe expanding that, and then using my box process to expand the two polynomials, and see if you get that. If you get that, then you know you've got the right factors. On to the next one. And this is the right answer, by the way. On to the next one. So right away, we can see we're dealing with a very annoyingly large number at the end, 24. 270 rather, 24, I don't know why I said. So we're also dealing with a 4 in front. So normally you take 4 and you multiply it by 270, and you're actually dealing with the number 1080. Well, there's could be a gazillion factors of 1080, so obviously 1, 2, and 3 are the easiest ones to start with. Also note that that's plus 270 in the beginning, and that these big numbers here are plus, so we're pretty much certain to be working with a negative number. And I can also say from 1, just starting with 1, I get 4 plus 7 minus 80 minus 21 plus 270. Well, that's 100 plus 270, so 1's not even going to be close, even if it's minus 1 or plus 1. So I'm going to jump right to 2. And also note, I'd say that you're probably dealing with a positive number. Actually, you might be dealing with a negative number to get these quite low. But let's start with positive 2. So it's 4 times 16, which is 64. Then it's 7 times 8, which is 56. This is positive 2 I'm doing. Then it's minus 80 times 4, which is 320. And then it's minus 21 times 2, which is minus 42. And then I got to see if all that adds up to negative 270. Well, this first part's 110 minus 320. So that's minus 210. And minus 42 is the last part. Does not add to 270. However, it is so close, I would be careful and check again. So 2 to the power 4 is indeed 16 times 4 is indeed 64. 2 to the power of 3 is indeed 8 times 7 is 56. 2 to the power of 2 is indeed 4 times 180 is indeed 320. And 2 times 21 is minus 42. It's clear that's 342 there. You can always break this down if you're not sure into this. It's clear that this is 100, right? So you can take 100 off. And it's clear that this is going to become 222. So 2 is not it. Let's check out minus 2, though, because minus 2 could raise it up enough to get us. Now, it's also good to keep your original numbers by, because you'll discover for the even exponents, minus 2 or plus 2 will still create the same numbers. So it's still going to create 8 times 4, or 16 times 4, which is 64. It's only going to change the odd exponents. So this is going to become a minus number, and it's going to become minus the same number you had before. So minus 56. And then the minus 21 is going to become the same number, just with a negative, with a positive sign in front of it. So that's going to become 42. Very quickly, if you add it up, you can see that this is 100. This is 56 minus 64 minus 56 is 8, and then 8, and then minus the 320 is minus 328. When I add the 42 here, it's again very close. We're talking like negative 2, 12, 88, something like that. So again, I would make sure of your math. So I'm going to just pull up the calculator and do 2 to the power of 4. It's negative 2, but that doesn't matter when it's an even exponent, times 4. Then I would just add it to your memory. Then I would clear it. Then I would go make sure I'd get the negative correct here. And to the power of 3, it's 8 to the 7. And I would add it to my memory, and then I would clear it. Then I would do 4 times 80 and make sure I get the right exponent. And I would add it to my memory. And there we go. And then the last one, I would do 2. Oh, I think I did I think I was working on minus 2, and I did So whenever you feel that you might have done something wrong, clear it all up and go again. So I was working on -2, and I think I forgot whether I put -2 in correctly or not. So times this first one is indeed that times 4, and it's positive. Okay, and I'm working with -2. The second one is -8 times positive 7. So yeah, I did get it right. Okay, this next one is indeed 80 negative times 4. So I did get that one right. And this last one is the only one that turns positive. So it's 21 times a negative 21 times a -2 becomes positive 42. Then you hit recall to see if you get a -270. Perfect reason why you check your work. I did some basic in my head calculations wrong, and it's clear that -2 is a root, which means that x plus 2 is a factor. Perfect example of doing things too quickly and just having a rough idea that maybe you did two things too quickly. Then you just use synthetic division. You take the numbers in front of all these numbers here, 4, 7, and I like a lot of space, 80. Always show your work. You're going to get lots more marks, especially if you do as I did and screw up a number. And then you're going to go again. And you start by bringing the number down. 2 times 4 is -8. Then when I add these, I get -1. -2 times -1 is positive 2. Oh, and look at that. I did it again. It wasn't x. No, I got it right. It was a -2 is the root. So I got 4 minus 8, positive 1, times, -1, times -2 becomes positive 2. When I add that, I get -78. When I multiply by -78, I get 140, 156. When I add these two together, I get 135 as the last number, and it's positive. Try to always include your signs. And the last number makes a -270, and these cancel out, so it's 0. So I know I did it right, which means I have 4x cubed, one less than your last one, minus x squared, minus 78x, plus 135. And we have some of the same dilemmas. Some of the same dilemmas are we're dealing with a huge number at the end that could have many, many factors. But here's the thing. You should check 2 out as well, positive 2, in case you made an error, because we made an error with -2. But they're not going to be totally cruel to you and use a 5 and a 6. They're going to use a 1, 2, or 3 as a test factor. And if they don't, they're just being jerks. So I'm just going to make sure I got the 2 correct. I'm going to use the same method. Oh. Yeah, so I'm using 2, but I'm using it in the new number. So positive 2, just in case I made an error before. And I'm going to multiply by 4, this one, and I'm going to add it to memory. Then I'm going to do, it's clearly 4 negative here, and I'm going to add it to memory. And then clearly it's going to be minus 78 times 2, and I'm going to add it to memory. And I'm going to see if my memory comes out as minus 135. No, very close, and I remember that's what I got, so at least I got that right. Now it's clear to me if I use right here, this is going to be a big positive number, and if I use a big positive number here, that's going to be huge. That's going to be a bit smaller, and that's going to bring it down a bit too. So actually I should check out positive 3 and -3. So I'm going to start with positive 3, and that's 3 times 3 times 3 is 27. And times 4, I'm going to clear my memory just so I don't make a mistake, and I'm going to add it to memory. So that's the first one. Then it's 3 squared, but it's negative, and I'm going to add it to memory. And I'm going to clear it. And then finally, it's 3 times -78, and I'm going to add it to memory. And I can see my number. You see how that number is way too big? I'm going to recall my memory and see if it's -135. Oh, it is. Isn't that nice? So positive 3 is a root, which means a factor is x minus 3. There you go. So now you do the same process. You're taking the leading numbers coefficients from your polynomial. You're trying to write it down correctly. Give yourself lots of room. And then you're doing the reverse long division box just to keep things neat. And I can see I've got a 4 here. When it comes up here, it's 12. When I add them together, I'm left with 11. When I multiply by 3 here, I got 33. When I add them together, I get minus 45. And when I multiply that by 3, I get minus 135, and they cancel out. So right away, I can see that my new factor is 4x squared plus 11x minus 45. And don't forget that it's 4x squared. So our next step is to use old school factoring and look at this number, 4, times this number, negative 45, and ask ourselves, do I have any numbers on a guess that is going to add up to minus 180, or multiply out to minus 180, and add up to 11. Now, the secret to this one is to realize that this number is so small and this number is so huge that the multipliers are probably going to be really close together, like 18 and 10. When I add those together, when it's minus 18 and plus 18 and minus 10, when they add up, it's 8. So it's going to be right around there. And that's the secret I've learned from doing these big numbers, is that when you know the addition's really small, these factors are going to be close together. See the 8 and the 10. And when you know this number is really huge, these factors are going to be far apart as numbers. So I'm very close. So I should just see if there's one less than 10, which would be 9, negative 9. And immediately I see, yeah, negative 9 and positive 20 add up to positive 11 and multiply out to minus 80. Now I'm going to use my slip and slide method, because I like the slip and slide method, which is just take the roots you found, plus 20 and x minus 9, and then take the number that was in front of this number over here, right here, which is 4, and you just divide them each by 4. And if they can divide, great. If they can't, great. And you should also see if they simplify. Right away, I can see that this simplifies to 5, and that 9 over 4 does not simplify at all, nor does it divide. So I immediately, here's the slide method, I immediately take that 4 and slide it over here. Now, if they had both been able to divide by something, I would reduce them first before sliding. And I'm left with those factors. And if you test it out, I get 4x squared minus 9x plus 20x, that's plus 11x, and minus 45. It works. So you figured out the last numbers. So I'm going to get x plus 5 is the last one, and 4x minus 9. And by the way, some books will then ask you to figure out how to graph this. Well, we're dealing with a quartic, right, to the power 4. So you know the end behavior of a quartic. It also has a positive leading coefficient, right? It had a plus 4x squared in front. So as a quartic, you know it's going to start up here, do something maybe, and end up here. You also know it crosses the x-axis 4 times from this. It crosses at these numbers, minus 5, 0, minus 2, 0. It crosses at 9 over 4 is 2.25, 0, and then it crosses again at 3, 0, which means if I were to guesstimate, I can guesstimate that this will create quite a deep one. I can guesstimate that this will also create quite a high one, and as I remember, the y-axis could also be determined, and I remember it being way up here. For instance, the y-intercept, rather, in this one is 144. And this last one does something like this. And then finally, the beginning and the end points are like that. And if you're going to draw it, try to also remember to include these little arrows. And also include the y-intercept as a point on your graph. Don't forget to put the actual points here. And sometimes if you find a number right between these two, you can get close to the bottom and the top. And as we learned from before, the rate of change is 0 at those peaks, which is a hint. We're going to be finding those peaks by finding the slope at those peaks. And there you go, you're able to draw it. I know there's questions in this book that want to draw it. Good. Now, this one, it looks like hell, but we can notice right away an x can come out of it. And we're left with x cubed minus 5, sorry, x to the 4 minus 5x cubed minus 7x squared plus 29x plus 30, which is going to help us a lot. And just remember to put this over each. There. And right away we know one of the factors is x, which means it goes through origin, which means it doesn't have a y-intercept, which makes sense because there's no, well, the y-intercept 0, 0, I should say, which makes sense because there's no number here. Now all we have to do is work with this, which makes it a lot easier than working with that. And of course we should notice the plus 30 over here. We can see right here this would make plus 29x. So 1's probably automatically not going to do it. We should check out minus 1 though. And we get this. And we should just see if that all adds up to 30. So I'll make sure I got it right. That's minus 5, that's minus 7, that's minus 29. So I got minus 36, minus 41, minus 40. Close. Minus 1 was close. And you should check again just to make sure. So I'm just going to check for 1, even though I know 1's not going to work. Plus 29 plus 30. Right there, that's 59. There's no way that negates the 59. And I should check the minus 1 just again to make sure I didn't make an error. So that's plus 5. I might have put it as minus 5. Yes, look at that. Why is that plus 5? Because it's minus 5 times minus 1. So that did indeed create an error for me. Because 30 plus 5 plus 1 is 36. And minus 29 minus 7 is minus 36. So right away, I made an error. But I did figure out that x plus 1 is indeed a factor. Because minus 1 is a root. Which means I can just start with this. By the way, I should keep that just in case. Which means I should find the coefficients in front of here. And anytime I'm doing these problems, you need to stop and try to do the problem ahead of me. Because there's no point in just watching me do it. It's not the point of these videos. The point of these videos is you can see how it's done once, and then you need to practice them to ingrain them in your memory. Don't just copy answers into the book. You will actually fail the course doing that. Okay, so I simply bring the 1 down. I multiply by minus 1 here, I get minus 1. I add them together, get minus 6. I multiply by minus 1, I get 6. I add them together, I get minus 1. And you'll know you made a mistake if it doesn't come out as 0 in the end. I get 1. I add them together, I get 30. And here I get minus 30. And notice, actually, especially when it's 1, that the number here is going to be creating that number. So you can pretty much predict what that number is going to be. Which means I have the new roots. I've got 1x cubed minus 6x squared minus x plus 30. And I just have to remember to put the numbers over them. Almost there. So 1 was very good. Minus 1 was good. 1 was no good. And we start the process again. We again can look at the number here for certain hints because it's 30. It's endless. And we're up to 2 and minus 2. And again, I would suggest that we have to be probably working with a minus 2. So I'll try minus 2 first. I get minus 8, minus 24, plus 2, plus 30. Oh, look at that. Plus 30, plus 2, 32, minus 8, minus 24. So it's indeed minus 2, which means my new root is going to be x plus 2. Sorry, my new factor. And then I simply take my minus 2, put it here, and write down my coefficients to this polynomial. Do my little reverse box. And start by bringing down the 1. Minus 2 times 1 is minus 2. Add them together, I get minus 8. Minus 2 times minus 8 is 16. Add them together, I get 15. And the last one cancels out. If it doesn't, you did something wrong. So I'm left with a quadratic of x squared minus 8x plus 15. And I just do old school factoring. By the way, a good trick to figuring out how to factor something like big, like 120. So clearly it's always 120 and 1. But start by dividing by 2. Then as you double this, if you can half that, it's a factor. See? Those are all factors. I'm doubling this. And if I can half that, it's a factor. And look, I can come up with quite a few like that. And I can still get one more, 64 and 5. Oh, I did something wrong there. 160. Yeah, I did do something wrong. This first one's not. It's 60. Sorry. Well, I could have used a very big number and it would have worked out. So 2 and 60. And if you can double this one and half this one, you can keep going. 8 and 15. Okay, I can't double that anymore. But we can come back to this one, or even this one, and say, can I divide it by 3? I can. 3 and 40. Well, if I can double that one, 6. Can I half that one? Yeah, 6 and 20. If I can double that one, 12. Can I double half that one? Yeah, 10. I can even get one more in there, 24 and 5, and I can no longer do it. Okay? I can't go back to 4, but now I can say 5, but I already figured out the 5. Do I have a 6? I already figured out the 6. Do I have a 7? 7 doesn't work. It goes in once and then has 50 left over. Do I have an 8? I already figured out an 8 here. Do I have a 9? No, 9 doesn't go in. I already figured out a 10. So you can see you can figure out a lot of factors with this process. That's just an aside. In this one, I'm trying to figure out something that multiplies out to 15 and adds up to minus 8. And I indeed have minus 3 and minus 5. Which means my last factors, because it's a simple parabola, is x minus 5, x minus 3, and we're done. Took a while, but like I said, they're not going to throw really hard ones at you when you're learning in terms of really hard roots. And that's the correct answer. And now we're going to move on to this last one. Can I factor out an x? No. Can I factor out a number? No. So let's start with just 1. This is plus 24, so I'm pretty sure just 1's not going to work. 40, that's a big number. So I'm pretty sure 1 period isn't going to work. I'll put the negatives on a different line. Do they cancel out each other? No, they don't. Shouldn't have even bothered. But I should keep the numbers just because it'll be easier to add them up. So this is going to be a minus 2. This is going to be a minus 23, and this is going to be a plus 24, and it's clear 1's won't work at all. Let's try 2. Let's try negative 2 first, okay? I'll write it over here. So negative 2 here is 16, and then it's going to be a negative number here. It's going to be negative 16, so those cancel out. Over here, it's going to be 2, 4, 46, oh, it's going to be a negative number. It's going to be 4 times 23, which is 92, negative 92. And this is going to be a positive number, plus 48. And right there makes me want to make sure of my work. Right there, I just feel like I might have gotten something wrong. So I'm going to do the trick I was doing before. I'm going to add that. So this all adds up to negative 144. I got it. No. Makes me suspicious, though. because I think it was bigger than minus 44. Makes me think I did it wrong again. Yeah, I think I did do it wrong. So I got 16 positive. Oh, I think I didn't clear it. 16 positive. 8 times 2 negative. So those cancel out. Right away, there's nothing left. Oh, that's what happened. So there's nothing left, and the last two are not going to do it. No. Okay. So that's fine. So you could check 2, but I know 2 is just going to be more positive numbers than negative. So I'm going to jump straight to negative 3. I might have to try negative 2 again just to make sure. And actually, I shouldn't just jump like that. I should be, you know what? Let's go back. And we'll start with negative 2, because you never know. Unless you have a really good grasp of the numbers. Actually, I did negative 2, didn't I? I think what I was saying was 2 itself. So I already have the first 2 in there. So 8 times 2. It's not 32. So I'm just going to clear it. I know those two add up to 32. And 4 times negative 23. And then 24 times negative 2. And I'll just see if that adds up to negative 44. It's so close. It makes me worried that I made a mistake again. The first two numbers are 16, so I'm going to add it twice. 4 times negative 23. I'm going to add it. 4 times negative 24. I'm going to add it. And try again. Yeah, I didn't, although the number came out differently twice, makes me worried. Anyway, jump straight to negative 3. And if this adds up to negative 144, god damn it. Okay, we'll try positive 3. I think I did a mistake on the negative 23, or negative 3 rather. There we go. So negative 3 is, or positive 3 is indeed a factor. Positive 3 is indeed a factor. So, I think I figured out negative 2 and positive 3 so far. Now I even forget what I figured out. Oh well, it'll come out in the synthetic because it won't work if it doesn't factor in. So I'll try x plus 2 I know is 1 and x minus 3 is another. So if I got those wrong, the synthetic will straighten it out. It might be x minus 2. So I start with the numbers 1, 2, and I might have done 2 at once there, minus 24, 144. And we'll just start with 3. Okay, so this is definitely 1. I got x to the 3 plus 5x squared minus 8x minus 48. Okay, these questions take forever. And I can't remember if I figured out if 2 was 1 or minus 2 was 1, but I'm going to just check 2 very quickly. Synthetic division is so fast that you could even just get away with trying synthetic division over and over again to see if you get a remainder of 2. So I think I forgot if it was minus 2 or not. Nope. So I can try positive 2. Notice that the synthetic division sometimes is even faster, and I would recommend trying it. So I just ruled out the 2 very quickly. Let's just, in case I made a mistake, rule out the 3 using synthetic division. And actually I'm going to keep those numbers there. And I'm just going to try minus 3 as a root. Okay. Okay, we got 1 here. Minus 3, add them together, 2. Multiply, minus 6, add them together, minus 14. 3 is 42. Close. Just make sure my math. Minus 6, add them together, minus 14. Yeah, almost. It would be, this last one would have to add up to 16. I'd have to come up with minus 8 somehow. Very close. So we've ruled that out, and I hope we've ruled it out correctly. So that means this is not a root. And we're going to jump straight to 4, and we're going to use synthetic division instead of what we were doing, because it's pretty fast. And again, I should have kept all my numbers here. Okay, so we go 1, multiplied out I get 4, get 9, multiplied out I get 18, add them together I get 10, and right away I can see that 4 is not going to work. So 4 is out, so I'll try minus 4, and minus 4, and again I should keep all those coefficients. And minus 4, I'm going to try. So again, it comes down to 1, minus 4, 1, minus 4, minus 12, and 4 times that. Oh, there we go, plus 48. So minus 4 is indeed a factor, which means, and actually it's not bad to just do it the way I just did it, instead of trying to figure out the formula, and which means I'm left with x squared plus x minus 12 as my quadratic, which is clear. It is this. Oh, look at that. I got the same roots twice, right? Which means this happened twice, and this happened twice. Okay, which means if I were to draw it, and by the way, you had 144 as a y-intercept here, so it goes way up. I would draw it like this, minus 4 comma 0, and then way over here at 3 comma 0. And this thing comes all the way down, touches on the y-axis once, goes all the way up through the y-axis, and actually it'll go all the way up on this side, and on the way down go through that, and touch that and bounce all the way up. So it only touches the x-axis twice. And you should mark your intercept, which we got from the original formula. So you can see here that synthetic division was actually faster than plugging in -4, and also has a lot less error. So it's not bad to give, if you feel more comfortable just doing synthetic division if it's faster, go ahead. Factor fully is no different than doing synthetic division. So let's just see if we can do synthetic division faster than trying to plug it into the formula. However, you will discover, especially if you're allowed to use a calculator, a graphics calculator, that plugging in the formula is a lot easier. Notice we've got all our factors here. Let's just try synthetic division as a method. We're going to keep these up permanently, and we're going to just go through 1. And boom, we can rule out 1. Now we're going to try -1. And boom, we can rule out -1 because we're not getting a 60 over here. So we know it's not 1 or -1. Go on to 2. There we go. So right away we got our factors. We know that one of the factors is x minus 2 because the root is 2. And we know we're dealing with x squared plus 11x plus 30. And we know that 3 times 10 is 13. Just make sure I got my math right. 22, 30. Yep. Okay. 6 and 5. You should be able to get that fast at factoring. Now I could graph it, so I think there's a chance on the next question. Yeah, they're going to want us to graph it, so I'm just going to keep that there. And I'm going to keep it with its main formula because there's some information there as well. And I'm just going to put it on a new page for graphing. Okay. And I'm going to get rid of it. And I'm going to use synthetic division again. Get rid of that last question. Notice we're missing some things here. We're missing a 0x squared, so just to have a 0 in there. So my coefficients here are this. If you miss the 0, it screws it all up. I'm going to start with 1. You might think you got it here, but right away that doesn't add up to 0. It adds up to -12. So I'll just make sure of, which means -1 is probably going to work. But I'm just going to make sure of the numbers. Yeah. So now we're going to try -1. Nope. Again, you'd be tempted to think 1 is a factor, but it's not. So we're going to do 2. Tricky, tricky. You'd be tempted to think that's a factor, but it's not. At least I hope I'm right. I hope I'm not doing a basic thing wrong. Did I get all the coefficients right? Yeah, I did. Okay, so we're going to switch to -2. Still not a factor. try 3 and then minus 3. Ah, there we go. Those finally cancel out. So that means x minus 3 with a lot of red herrings. We're left with x squared plus 3x plus 2, which means that we're talking about x plus 2 and x plus 1. So I screwed up somehow there. Yeah, I screwed up somehow. Minus 2 and minus 1 should have been factors. Let's try that again. It says minus 2 and minus 1 should have been factors. Now here's one where you should probably expand it to make sure you get the right one. So I'm saying minus 2 times this is minus 2. When I add it up, minus 2 plus 4 minus 3. Oh, nah, you idiot. Indeed, that's plus 6. Okay, so that's just some arithmetic errors on my part. But I'm going to grab this and the whole thing and put it on this page. Oops. And delete it. Go on to this one. Lots missing in this one. Let's move these over. We're missing an x cubed. So we've got 1, 0, minus 5. We're missing an x. And then we got a 4. Start with 1. Might work out. Okay, so x minus 1 is indeed a factor. And I'm left with x cubed plus x squared minus 4x minus 4. Okay, we're going to go on to the next one. And we're going to rewrite our new coefficients. 1, 1, minus 4, and minus 4. And we're going to try negative 1 this time. Looks pretty good. Yep. So that's a factor. And I'm left with x squared minus 4, which I know from experience is a difference of 2 squares. Notice the first one is also a difference of 2 squares. Great. Now I should have kept a copy of that, but that's okay. I think I will actually keep a copy of it. C, just for the y-intercept. Good. On to the next one. Oof. I'm not missing any terms on this one. You can see synthetic is actually a little bit faster than plugging it in. And when they don't say specifically, you're allowed to use any technique you want. I'm going to start with 1. Here's where things get tough. Nope, doesn't work. So 1's not it. We're going to do minus 1. Whoops. So I'm going to keep the top numbers. Oof. sure I got that one right. It's that 38 that's throwing things out of whack. Oh, I did not get it right. Right there. That's plus 40. That makes plus 64, which makes this negative 64, which means x plus 1 is a root. And it even gives me my next one, x cubed plus 2x squared minus 40x plus 64. And I continue with my new coefficients. My new coefficients are 1, 2, minus 40, and 64. And I'm going to move on to 2. Bingo. Which means one of my factors is x minus 2. So synthetic division is actually much faster than plugging it into the formula and has a lot less errors. And finally I'm left with x squared plus 4x minus 32. And you can ask yourself, since the 4 is not far apart, we're looking for factors of 32 that are very close to each other. So like 8 and 4 plus 8 and minus 4 multiply out to negative 32 and add up to plus 4. So right away we get the bigger factors, x plus 8 and x minus 4. So I'm going to just make a copy of this and a copy of that. And copy it over to this one. And continue. And after graphing them, I think I'm going to stop. Just to avoid errors. Okay. This one's a little easier because it's only a cubic. These are the coefficients. So you can see we're probably dealing with 1 or minus 1. Yeah, there's one of them. So after factoring out x minus 1, I'm left with x squared plus 1. Now you might be tempted to think that that has another factor, but it doesn't. And you also might say, well, what happened to the x? Well, this is 1x squared, which is 1 less than this, 0x, 1 less than this, and 1. Because when this goes down to 0, it becomes just a number. So I'm left with x squared, no x, and a 1. And you might say, well, how's that on the graph? You're right, it won't be on the graph, because for it to exist, so yeah, it's positive 1. Yeah. So for it to exist, x squared would have to be equal to minus 1, and it doesn't. If you were to map this out, you'll discover that there's only one x place it crosses. So it's going to wiggle a bit either above or through. It's either going to go through. It's probably going to wiggle a bit down below and then go through 1, 0, and also goes through the y-intercept of minus 1. And we'll see on the graph. And the last one, and we're going to keep the last one on the screen to graph it, is a long power of 5 one. We're talking about 1, minus 1, 2, minus 2, 1, minus 1. We're probably going to have a lot of missing holes in this one. There's one. So one of the factors is x minus 1. And that would leave x to the power 4 plus 2, well here, plus 0 x3 plus 2x squared plus 0x plus 1. This just helps you to, let's make a copy of this over here. And this can go up, and I get my new coefficients. This just helps you to keep it in order. My new coefficients are 1, 0, 2, 0, and 1. And now I'll try negative 1. I think I got it right. And that one doesn't work. So now I'll move on to my 2's. Whoops. You want to keep your coefficients around. Nope. So I'm going to try negative 2. Nope. That's interesting. So I'm going to try 3. I don't think 3 is going to work either. Getting out of control. Let me have a look at that. I got it. My bad. X to the 4 plus 2x squared plus 1, I believe, can be factored as x squared plus 1 squared. When I expand this, I get x to the 4 plus 1 plus 2 times x squared times 1, which is 2x squared. So this is what I'm left with, I believe. This one I might verify. X squared plus 1 squared times itself. Now, let's get to graphing this. And then for this one and the last one, I'm going to use Desmos to confirm. First of all, always look at your biggest term, x to the 5, which means it's starting in this, and it has a positive leading coefficient, which means it's starting in this quadrant, just like a cubic or any odd exponent, and it's ending in this quadrant, and it can cross the x-axis up to 5 times, and it can have up to 4 turning points. But in this case, for this to be equal to 0, x squared must be equal to minus 1 to create a 0 in this bracket, which can't happen, which means it only crosses the x-axis once, and yes, all odd exponents must cross the x-axis at least once, which means it either wiggles down here and crosses at 1, 0 and goes on, and also notice it has a y-intercept of 0, minus 1. What these turning points do is unknown, but since on the left side of this it is crossing the y-axis at minus 1, we know it's all going to stay down here as opposed to crossing here and bouncing around. Now what I'm going to do is type this into Desmos, and I'm going to type this into Desmos and see if we have the same graph. But if you're going to graph it, you're going to mark down the y-intercept, 0, minus 1, and you're going to put a dot on it. And how do I know the y-intercept? Right up here. When x is 0, this whole thing disappears, and we're left with minus 1. So you put it in brackets, and you put a little dot right where it is. You always label your stuff like this. Then here's the other x-intercept. That was the y-intercept. The x-intercept happens to be at 1, 0. And you label it. And you can always explain why you know the graph starts here. You do not know how it's going to behave. You do know it's going to go through there. So you have a line like this. You know it's going to behave something like this, and then it's going to go through there and go shooting off into space. Also, because of this, I would suggest that it just does some weird bounce once and then goes shooting off into space, just because this is the same root twice. Let's have a look. X minus 1, x plus 1 squared. X squared plus 1 squared. Oh, it even does a weird slippy slidey. It doesn't even do a turn. So this weird situation here creates this weird bending thing. So it doesn't even ever have a turning point. And there you go. Now let's put in the original graph. Wish there was a way to cut and paste into it. X to the 5 minus x to the 4 plus 2x to the 3. X to the 5 minus x to the 4 minus 2x to the 3 plus 2x to the 3 minus 2x squared. So I'll just do another plus 2x to the 3 here and do a minus 2x squared here. And I remember that it's, what's these x value? Plus x minus 1. And sure enough, I get the exact same graph, which means I factored it correctly. And that's how you draw it. These are the only points you know for sure. And just from knowledge, you'll learn that this little thing here will create a, probably not a turning point. And if I zoom way out, it looks pretty much like your standard cubic, just adjusted downwards by 1. Okay, great. Let's go to this other one that was tricky as well. Very similar, except that it's not squared after. So if I was going to graph this, especially with my knowledge of the last one, I'm going to notice that it has the same points for y and x intercept. Only this time, it only goes through that once. So it's going to be, since it's a cubic, I'd say it's going to look the exact same. The exact same. And we're going to label it the same way. You do minus 1, 0, minus 1 here, and 1, 0 here. And you make sure you put your arrows on the thing, and you label your x and your y axis. And you note your y-intercept. And you can even explain why it starts in this quadrant and ends in this quadrant. It's because it has a plus leading coefficient and a cubic. And then let's see if Desmos confirmed this for us. This is what we're going to say the cubic looks like. We're going to turn this one off. And the cubic just is missing the square here. X minus 1. There it is. Oh, looks identical. Let's go back to the other one just to see the difference. Less bend. Less bend. So that x squared minus plus 1 squared created more of a bend. And then now let's go to the original graphic, x cubed minus x squared plus x minus 1. To see if we get the same one. So it's x cubed minus x squared plus x minus 1. And sure enough, we factored it correctly. Okay, now we're going to go to the next one. Okay, and this one, notice it's a x to the power 4, and it's positive leading coefficient, so it's going to start in this quadrant and end in this quadrant. Notice it has 4 y-intercepts, so it's going to have 3 turning points. And notice it goes through 0, 64. Way off the chart up here, but you would want to label that. You can possibly label that like this. This broken line implies that you're skipping some values, and then you can just put a nice little 0, 64 up here. That'll help you draw it, by the way. What's the leftmost leading point? It's right here. It's -8, 0. And make your numbers a bit smaller than I'm making them. What's your next leftmost leading point? -1, 0. What's your rightmost or second rightmost leading point? 2, 0, and then 4, 0 right here. And I'm just going to make this a bit smaller to have some room. Now that you've labeled all your points, you should put little dots where you feel they are. It helps if you use graph paper, because obviously these points are not proportionally drawn. And I'm going to be, because these 2 points are way far apart from each other, I'm pretty certain it's going to dip. It's going to dip way down, like way down, further than I can represent it. And then this part here is going to dip way up to the 64 part. And I can't quite get it there. Let's just pretend that's it. And then this one's not going to dip down too much. Dip down like that. And these points here are going to go off forever this way. And off forever this way. And because this spot here is way down, you're actually going to see like you're actually going to see something more like this on this side. And it's going to go down way more than -64. It's going to go way down like that. Just to give you an idea. And so long as you've labeled your points, and then don't forget to put these little arrows at the end, and label your X and your Y axis, you should get some points. And you can even point out how you know certain things. And now we're just going to compare this. Make sure we got it right. So x plus 1, so x plus 8, x plus 1. When your hands don't work for you. And sure enough, look at this. I'm going to just change the values of y so we can see that it's going down to -200 and up to 80. There we go. Gives us a good idea. In steps of 10, doesn't matter. 100. Look at that. See how far it dipped? Look at that, -807. And I knew it dipped way down because the distance between 8 and this intercept point and this intercept point, this distance between 8 and -1 is 7 apart. This one between 1 and 2 is only 3 apart, and it got us up as high as 64. So I instantly know that if it's 3 apart and got up as high as 64, when it's 7 apart, it's going to go way astronomically down. The only way you could figure out that point is to take roughly -5 here and figure out, plug it into the equation and figure out how far it goes down. And you can use graphing calculators for that. And you get a rough idea of how far it goes down. Now you still can't quite find the peak until you learn derivatives, or the minimum until you learn derivatives. But notice that is indeed the lowest point of the graph. And this is what's called a local minimum, which means it dips down but doesn't go the furthest down. And this is a local maximum up here. Notice that when it crosses to the y-axis, it still goes up a bit. And just to make sure we got it right, you can write the original equation, which this is the last time I'll write the original equation. Well, we can see we're dealing with x to the 4 plus 3x to the cube. You see my memory isn't very good anymore. Cube minus 38x squared plus 24x. And what did I say? Plus 64 or minus 64? Plus 64. So notice we nailed the factoring because it's the same graph. So there you go. Now I'm going to just graph the others. I'm not going to use Desmos anymore. But yeah, I just wanted to verify our work. So there's our new one. Now this one is going to come down and dip like that. So I'm going to just get rid of our old values. And, oh no, it's going to be very uniform though. This one might be worth drawing. Minus 2 comma 0 is a point, minus 1 comma 0 is a point, 1 comma 0 is a point, and 2 comma 0 is a point. Now notice they're all equidistance apart. Actually on the left they're 1 apart, in the middle they're 2 apart, and then 1 apart. And we also know the y-intercept here, 0 comma 4. And because they're on equidistance, I'm going to say 0 comma 4 is going to be the peak right here. Which means I'm willing to bet that these two go down half the value. I'm willing to bet we can find the minimum values on a guess. And then you would draw this last part. Now I'm willing to bet that they go down at negative 1.5 here to negative 2, and at 1.5 here to negative 2. And simply because it's so uniform on equal sides of the x-axis that because this is double apart and goes up to 4, and this is 1 apart, this is 2 apart and goes up to 4, this is 1 apart, I bet you it only goes down to negative 2. So I'm tempted to I'm going to probably just plug the factored form quickly into Desmos, but you will have a beautifully uniformed W. Let's have a look. Hope so we zoom in a bit. I don't think it went down nearly as far as I'm zoomed way out. No, not quite matching any predictable formula, but close. Minus 2.25. Also didn't hit right in the middle of it, and that's, I should have known, that's because the left side of this is so much higher that it's going to lean towards the left side on the peak at the bottom, and the right side up here is racing up so much higher that it's going to skew the peak to the right side over here. So you can see it's slightly to the right of 1.5 and slightly to the left of negative 1.5. But still very uniform. This peak here is the same as this peak here in terms of the y values. And look at the x values, identical. So at least I could have predicted that these would be the same values because they're uniformly spread around the y-axis. And sure enough, that is indeed the peak in the middle. And that's because it's already been stabilized equally on each side. Hard to know exactly what I mean by that, but essentially because everything on this right side is the same as everything on the left side, it's going to be equally balanced down the middle here. All right, Next one, a little bit easier. We're dealing with a cubic. And if you note, the y-intercept is going to be below it. So right away I can see that the y-intercept's here, 0, minus 6. It's in the main equation. And I can see that at minus 2, 0, minus 1, 0, and way over here at, this one's way over here at 3, 0. Which means, because I have a leading coefficient, it's going to come up like that, come down like that, going to be way down here, and go up. And I'm even going to say that the middle point between these two is 1. I'm going to say the bottom area is about 1.25, and you're going to see something in the neighborhood of, negative 30, something like that. Maybe negative 20, actually. So let's have a look. This one I can definitely graph, and you want to graph it nicer than that. So it's a cubic, which means it starts in this zone and ends in this zone, in this quadrant. And you can draw a nice little peak here. It's not going to go up very high because it didn't have much time to go up very high. But this one here, if I were to draw it to scale, will go way down. And then you just draw your last lines like that. And be sure to label all your spots. Sorry about that last one, but you get the idea. And this I can quite quickly throw into Desmos. And look at that. Now let's look at this. Yeah, there's the 1.5 and negative 13. So it didn't quite go down, but it did go down a lot further than this went up. And that's because it was on its way down at minus 6. But we got the drawing perfectly. You could even plug in, like I said, you could make your graphics calculator equal to f of x and plug in on a guess f of 1.5, and you'll come close to how low it dips to make your graph even more accurate. And it's just guesstimations, right? And because you know it's going to be between 1 and 2, you can come close at 1 minus 1 to figuring out the peak here is going to be about there. Just by plugging this into the equation. Even by manually, you can sort of figure it out. And it just gives you a rough idea of where your peaks and your valleys are. Great. Last one. Last one is this one. It's a cubic. Pretty straightforward. Actually, I'll just use this. Because it's a cubic and a positive leading coefficient, it's going to start here and end there. And the points it goes through here are minus 6, 0, minus 5, 0. It helps if you make those numbers smaller. And 2, 0 over here. And it goes way, 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 way down to 0, minus 60, which we can't visually quite get on this graph. But that means there's a huge dive down here. And since the distance between 2 and minus 5 is 7, roughly here at negative 1.5, you will find the valley. And here at negative 5.5, you will find the peak, which is going to be very small. Just very quickly. Well, actually, it's going to be quite big. Negative 7.5 times 3.5, negative 0.5 times 0.5. Actually, no, it's going to be quite small. It's going to be up here, though. It's going to be half of 7.5 and half of that. So it's going to be around, what is 3.75 and half of that? It's going to be around 1.8 peak. And if I were to take f of x at minus 3.5. So that means it's going to, the depth is even lower on this left side. It's on the way up when it passes through 0 minus 60. And plug it into the equation, I will get the number roughly of the bottom. Let's see that. Well, let me graph it properly first. I was just showing you how you can get even more information. It's probably too much information. Okay. Little bump there. And again, graphically, I can't quite do it justice, but it's going to go way down like that. And this is going to go, I didn't get the bump properly. Way up like that. So if I was to put it to scale, it would look like this. A little bump, way down and way up. And it's passing through the y-intercept on the way up. It's going through all these points here. Let's see how close I was. Plus 5, plus 6, minus 2. So the factored form is pretty easy to do. Okay. There we go. So sure enough, look at that. It's on the way up. And sure enough, if I put in f of negative 1.5, I'm going to get roughly minus 55, which is close. The no cigar. Oh, it's negative 0.5 I was supposed to look at. Sorry, the halfway point is roughly negative 0.5. Negative 61 is roughly as low as it gets. So you can get pretty close to getting the right one. And like I said, this should be about 1.8 up here. Yeah, 1.877. And there's the y-intercepts, or x-intercepts, and there's the y-intercept down here, 0.60. You get pretty accurate drawings if you know how things behave. And that's it. I'm going to continue the other questions at a later time.